Hi, and welcome to video 3 for section 4.3. This is the third and final video for this section. So the first thing we're going to do is look at an example. At the end of the last video, I was kind of throwing some ideas at you, like, okay, here's some information about the graph. So from that I know what the curve or what the function might look like. So let's look at an example where we put that all together. Let's say we want to sketch a possible graph of f that satisfies the following. First, f prime of x is greater than 0, is positive on the interval negative infinity to 1, and f prime of x is less than 0, is negative on the interval 1 to infinity. 2. F double prime of x is greater than 0 on the interval negative infinity to negative 2, and from positive 2 up to infinity. And f double prime of x is less than 0 on the interval negative 2 to positive 2. And then third, the limit of the function as x approaches negative infinity is equal to negative 2, and the limit of the function as x approaches positive infinity is equal to 0. So, we don't know anything else about the function other than this information. So let's start with number 3. This is the easiest for us to figure out to begin with. So as we go to negative infinity, this function gets really close to negative 2. So it's basically what? It's a horizontal asymptote at negative 2, and we're running real close to it down here. And as we go out to positive infinity, the function approaches 0. So my x-axis, something similar to that. Now, let's look at what the first two are telling us. First of all, f prime of x is positive from negative infinity to 1, and f prime of x is negative from 1 to positive infinity. So f prime of x is what? Our slope. So from negative infinity out to 1, we're running uphill. So this graph has to be going uphill the whole time until it hits positive 1. And after positive 1, then it turns and starts heading downward. So let's put these in some notes here. So the first part, negative 1, that means this is running uphill. And after we pass 1, this is running downhill. The second one is telling us about concavity. So f double prime is positive from negative infinity to negative 2, and from 2 to infinity. So if it's positive, that means what? That's concave up, concave up. So it's got to look like a coffee cup. And then f double prime is less than 0 from negative 2 to positive 2. So that means what? It's concave down, which means it's got to look like an upside down parabola between those 2 points. So now if we put this all together, at 1, so I'm just going to put some point here, arbitrary, I don't know what the value of 1 is, but from 1, it changes from going uphill to downhill. So I'm going to work on the left half right now. So I know from here this way, it's got to run downhill the whole time. And I know from negative infinity to negative 2, it's concave up. So I don't know what the value is at negative 2. I'm just going to make it easy on myself and make it go through the x-axis there. I don't know. It's just a sketch what it could possibly look like. Maybe it's down here, maybe it's below the x-axis, maybe it's above, I don't really know. I'm just going to make it 0. Doesn't matter. Then it changes to concave up, which means what? So from negative 2 up to positive 2, so from negative 2 at least up to 1, it's like an upside down parabola, so that's got to look like that. Now from 2 to infinity, it's concave up, so it's, again, this open coffee cup. And then from 2 back to 1, it's got to be the upside down coffee cup. So that basically is a sketch of what the function could look like based on all this number. Yours might be a little different. Maybe you didn't go through the x-axis, or maybe you had this point way down here. It doesn't matter. But the key is it's concave up till we hit negative 2, then concave down till we hit 1, then concave down till we hit 2, and then concave up as we go to infinity. So that's an example of if we're given information about the derivatives, we're able to sketch what a potential graph could look like based on that information. So earlier in this videos, I'm going to erase this here. Early in the videos we had the first derivative test. So this leads us to the second derivative test. And that says the following. We have first, if f prime of c is 0, so that means what? Horizontal line, so it has to be a max or min, and f double prime of c is greater than 0, then f is a local min at c. So again, think about it. F prime of c is 0, meaning it's a horizontal line, meaning it has to be a local max or a local min. And if the second derivative at that point is positive, so that means what? Positive concave up. So the only way it can be concave up is if it looks like the parabola or a coffee cup facing upward. So that means at that point c has to be the local min. And similarly, if f prime of c is 0 and f double prime of c is less than 0, then f is a local max at that point c. And same idea. F prime of c means it has to be a local max or local min, but because the second derivative is negative, it means concave down, meaning it looks like an upside down coffee cup or an upside down parabola, therefore that point has to be a local max. So that's what taking the second derivative. If we take the first derivative, set it equal to 0, that gives us the point c that's a local max or min. Take the second derivative, plug in that value for c, and does it make that equation positive or negative? If it's positive, we know it's a max. If it's a negative number, if it's If it's positive, it's a local min. If it's negative, it's a local max. So it's kind of like the opposite of what you think there. So unlike having to build that giant table, and here's my critical points, and let's use the table to figure out, is it increasing, is it decreasing, is it local max, is it local min, you can just do this second derivative test. Find where it's 0, our critical points, take the second derivative, plug those numbers in, and if it's positive or negative, it tells us if it's a local max or min. So that's it. That's the end of the third video. That's the end of section 4.3. Come on back and we'll look at section 4.4.